Now we're going to get our hands dirty with some more complicated shapes. I'm going to go through the cone, the rectangular pyramid, and the sphere. Those are all new shapes to you. I'm going to show you formulas to calculate the surface areas of those new shapes. Now, let me be clear about something. Just because I give you a formula for a particular shape doesn't mean you use that formula for every situation every time you run into that shape. Okay? Why?
Because it can be different.
Why can it be different?
Like the...
It depends on the circumstances.
Think about a cone. Okay? We'll be doing that just in a moment. If I just said, find the surface area of this cone, you would find the area of the bottom as well as the side here. Right? However, if I said, I have an ice cream cone made out of like waffle stuff. What's the surface area of the outside of the ice cream cone? What part would you not care about?
The bottom.
Yeah, the circle. Because when you eat ice cream, there's a big hole there to put the ice cream in.
So that
Right? So that would change the formula that you use. So don't make the mistake of being like, oh, this problem's got a sphere, or oh, this problem's got a cylinder. There's the formula. All right, I'll just use it. No. While you may not be required to memorize formulas, it's really important you understand how they're constructed so that you can change the pieces of the formula depending on the situation you're dealing with. Okay, you're going to have to do that a lot today. So you really got to pay attention to what's happening in your problem and what faces are relevant. Got it? Okay. So, we're going to find the surface area of a right cone. This is a right cone. Okay, they call it a right cone because the base is perpendicular to the height, but you don't have to really worry about that because all the cones you deal with in this course are right anyways. So we've got a right cone. They give us some dimensions there. I'm going to draw a picture. Please do the same in your notes of our cone. Okay, so I've got, if you draw just a triangle like that, and then the roundy part there, and then if you continue that circle by drawing dotted lines, it kind of shows it's going behind. Oh, yucks. Yuck, yuck, yuck. Drawing circles with styluses. Okay, so there's our right cone. What does it tell me? It has a circular base with a diameter of 27 centimeters. So that means that this distance is 27 centimeters. And, this is important, it's got a slant height of 40 centimeters. Slant height. That's a key word. A slant height is the distance from here along the edge of the cone to here. It is not the distance from the tip of the cone to the middle. That's just the height. The slant height goes along the slant. Okay? And the formula for the surface area of a cone is based on the slant height. So watch out for that. Alright? That slant height is 40 centimeters. Since this is just a generic cone, there's no context, every face matters, so we're going to find the area of every face. Now let's just think about this for a moment. What shapes do you recognize on this cone?
Circle.
There's a circle on the bottom. So likely the area of a circle is going to be relevant to our problem. But there's also this strange part, right? The part that goes around the top of the cone. That's called the lateral face. Looks a little strange, okay? But I'll give you a quick formula to find the area of that lateral face. If you look at a net of a cone, you've got a circular base, and then that lateral face looks like this. It'll connect right there, and it looks like that, which is kind of a strange shape.
What?
Okay? If you
If you took it apart.
Yeah, if you took it apart and drew a net, this is what it would look like. Okay? And this kind of helps identify the individual faces that you're going to find the area of. Right? The circle is just going to be pi r squared. And the lateral face is pi r s. That's how you find it. In this case, s is the slant height, and r is the radius like you would expect. Okay? So the total surface area of a cone, the generic formula, is pi r squared plus pi rs. Can you see why the formula is like that?
Because it's adding the formula of the circle
Mhm.
with the formula.
This is the circle. This is the lateral face. And it's important that you understand what those pieces of that formula mean depending on the context that you're working with. Because sometimes you'll only be concerned about the circle. Sometimes you'll only be concerned about the lateral face. It depends. You understand? Okay. Since both pieces are important, let's use that formula to find our surface area. Okay? So pi r squared plus pi rs. Pi, what's r?
Radius.
Radius. And the measure of the radius here is
13.5.
13.5, half of 27. So we're going to square that. Plus pi r 13.5. And what's s?
40.
40, the slant height. Okay. In your calculator, I would recommend doing this calculation, enter, then this calculation, and then add them together. You could store one value. I mean, you could also enter it just as is, but it kind of helps to avoid error if you do it in two pieces.
Square thingy.
The square thingy is 5 buttons down on the left. You see x squared. That will square your number.
You want us to round them?
They want rounding to the nearest tenth of a centimeter. So yeah.
So 1 decimal place?
Yep.
I got 2269.015294.
So to 1 decimal place would be just 0.0,
Yeah.
right?